Alright, I'm going to read from the Exercise Physiology book, Theory and Application of Fitness Performance, 9th edition. Scott Powers, Edward Howley, page 80. This will be a closer look, 4.2. Exercise and fat metabolism. Is low-intensity exercise best for burning fat? The big question. I like to answer in this other question here that we checked in that last video. What intensity of exercise is optimal for burning fat? At first glance, it would appear that low-intensity exercise would be best because a high percentage of energy expenditure is derived from fat oxidation. However, one must keep in mind that because overall energy expenditure is also very low at these low exercise intensities, only a small amount of fat is oxidized. For example, let's assume an individual is working at a 20% VO2 max and the metabolic rate is 3 kilocalories per minute. If the R, that was the respiratory exchange ratio. Let's go back. In case you weren't paying attention to our respiratory exchange ratio, the ratio between carbon dioxide and oxygen. If the individual, let's start that over. Let's assume an individual is working at 20% VO2 max and the metabolic rate is 3 kilocalories per minute. If the R is 0.80, 2/3 of the energy, 2 kilocalories per minute, is coming from fat, and 1/3, 1 kilocalorie per minute from carbohydrates. See table 4.1. Yes, we're going to look at that. If the individual is now working at 60% VO2 max, the metabolic rate is 9 kilocalories per minute. If R is 90%, or 0.90, only 1/3 of the energy is coming from fat. However, because the metabolic rate is 3 times higher, 3 kilocalories per minute are derived from fat, 50% more fat oxidation than at 20% VO2 max. Figure 4.13 shows changes in R and the fat oxidation over a range of exercise intensities. Fat oxidation increases until about 60% of VO2 max and then decreases thereafter. This is a fairly typical pattern of fat oxidation. The highest rate of fat oxidation is sometimes toward fat max, and there is support for a connection between the LT and fat max, the lactate threshold. In effect, the acceleration of glycolysis that is related to the rising lactate concentration in the blood signifies an overall increase in carbohydrate oxidation. Consistent with that, the fat max appears to be reached just before lactate threshold. In addition, fat oxidation appears to be higher at the same relative workload percent VO2 max during running compared to cycling in both adults and children. Any discussion of which exercise or exercise intensity is best for fat oxidation will keep in mind that the total energy expenditure is key in any weight maintenance or weight loss program. See chapter 16. Higher heart rate, burn more calories. Higher intensity, burning more calories. Might be using a greater percentage of carbohydrates, so muscle glycogen, glucose, lower percentage of fat. But let's see what this graph says. Okay. So there it was. Exercise intensity, VO2 max, 20%, 30, 40, 50, 60, 70. Alright, fat oxidation starts to lower down at 70. There's the crossover point of the respiratory exchange ratio. At 70% VO2 max, maybe 70. Fat oxidation. As respiratory exchange ratio increases, goes higher, more fat oxidation. Goes higher, fat oxidation does drop off. Looks right about 60%, but more calories. Okay. Figure 4.13, changes in the respiratory exchange ratio and in fat oxidation with increasing exercise intensities in active men and women. Fat oxidation increased from light exercise and reached a peak around 60% VO2 max. Okay. So we're going to hold off there. That was a closer look, 4.2, page 80. Oh, this is very, very important. See you later.